G'day, good evening. Thank you for listening. This is a medical show. I respect the law and I hope you do too. Information in today's stream is for scientific and educational purposes. The information is fact-checked and any websites or papers that have been gone through will be in the description below. If you're re-listening, watching this back, I haven't gotten to today's topic yet. So I wait for the viewers to choose or to ask questions, put up different discussion topics, things like that. And that's how I get the title. So you can fast forward through to, you see some slides or the screen change, and that's generally about 5 or 10 minutes in. Fast forward. And if it doesn't go past 10 minutes odd, it's meaning there was no show. Everybody's happy and not much discussion was going on. So I'll give it till 2 minutes, another 50 seconds. Wait for all the cool people to arrive, just like Genetic Memory Farms. G'day, mate. He says, good evening, peeps. I hope you're safe. I got to be up at work soon or I'd hang out. Much love. I have been well. Nice to hear. Hope you enjoy what you are doing tonight. In the Sunshine RB. Oh, Sunshine RB. Another 10 seconds. And then that's the 2 minute mark. And that means that I've got to say something. 2 minutes. Bing. So now what to say. People who are in chat, please put in any topics that you've heard that might be weird, some myths, some microbiology, plant science or science, soil science related questions or discussions, and I'll be more than happy to open up my slides and enlighten the subject. And it's been quite good. The last few shows, the topics that have been brought up, I haven't been familiar with, but I can do some research online here and we can go through the papers from what I see, and then I can give my educated opinion on what I think. So that was quite enjoyable because that's a learning curve for me too, because I don't know everything. I'm not a blooming computer. I've just got some good education that I've done in some really relevant plant science, soil science, and microbiology courses that are really on point. I really appreciate my education. It's really good. It just gets rid of a lot of the bro science that's just, there's too much these days. Anyway, Sunshine Rainbows. Do you recommend 50 perlite, 50 worm castings substrate for seed germination? Well, for germination. So that's producing the radical. That's not seedling stage. So to produce the radical or to get the seed to germinate, if that's what you mean, or do you mean in little plantlet size or seedling size? Once it's come out of its shell, once the radicals change into the root. Anyway, I'll answer the question what it is. So seed germination, no, I don't. I recommend using ethylene you need 3 things for seed germination. You need oxygen, temperature, and water. Let's just pull up this seeds. And I'll just prove to you why I won't use that substrate. Maybe for seedling growing, yeah, but not for germination purposes. One of my classes was, university classes, was Principles of Seed Technology. And that was a 12-week class on just seeds. That was pretty rad. So germination, 3 types of germination. I suppose we can go into this. I'll just see if he's, no, he hasn't changed the question. All right, I'll just go into that. 3 sips, How much is there first? Not much. Well, it hasn't gotten, I'd like to show that at least the temperature in the air. Okay. Not my experiments. Seed germination is based on the behavior of the cotyledons epigeel, hypogeel, and viviparous. This is the epigeel. So it means that it starts underground and then comes out. See the seeds underneath, and then it pushes out that way. That's not a good example. Why isn't it going left or right? Okay. This really want to get onto just the principles of the seed. How it needs 3 things. This is what I'm looking for. Maybe I should just go to that class. I'll go to that group, dormancy. I'll just go to this. It'll be at the start of this one. That seed technology class. Principles of seed technology. Oh, great. Usually week 1 goes into history. Oh, no, here we go. Looks like this might be into the area that I was thinking of. Is it in there? It's really the parts of the seed, which goes into great detail. We're not going to go into today. Seed coat. It's pretty rad, synthetic seeds. Come on, I know I'm picturing the diagram. Yeah. Seed development. Everything else is, it's a shame. I could discuss all these. Oh, nearly here. Well, for 3 things, this will do. Events occurring in the germination. So you need water, you need the right temperature, and you need oxygen. So you can see gibberellic acid is one of the hormones that is used or produced in the seed by the starches. So it first handles it breaks down into the amylase, breaks down the starch, because that's what it does, which produces the sugar, which goes and starts the gibberellic acid, which starts the cotyledon leaves. And ethylene is a good way of producing the rupture of the seed and getting the radicle to come out. That's all I really want to get to. Requirements of, here it is. Requirements of seed germination. Water. Water is required for hydration of the seed, enzymatic activity, cell division, and elongation. Requirements. And then you've got oxygen is required, inhibition of metabolic activity, and breakdown of stored food for energy in the starch. Radicle emerges from seed coat with aeration. And then you've got temperature. So temperature must be optimum. If the temperature is very high, then the seeds will emerge very fast and even wither. But it depends what the seed comes from, what area, because the seed's in dormancy until you put it under these 3 conditions. So unless it reaches the conditions it likes, it won't produce a radicle. That's what I want to go into. So maybe something else is good next. It's a shame it was right into the middle. That'll do then, maybe. Let's see if there should be some elaboration on that. There's not. Oh. So the answer, do you recommend 50% perlite, 50% Wurst castings substrate for seed germination? No. I recommend putting it under those 3 conditions, the temperature, water, and oxygen. So oxygen is pretty easy. So getting it the right temperature and water, and maintaining the temperature so it can't dry, maintaining the water so it can't dry out. And that's pretty much it. So to do that, you put in seeds in a little terrarium, or heaps of plastic around it, or plastic bags. It's good putting like in seed trays and then putting a big bag over the top of it, keeping it down. You know the moisture is going to stay in. Check it every few days if it's hot, and then you'll see it'll start and produce. It'll have gone through its germination stage into the seedling stage, and then it's different. And then you can pull them out and put them into the substrate, inoculate the roots, and keep it going. Oh, hang on, a bit of an update. What substrate do you recommend? For what? Because you asked about seed germination. Well, it's pretty much this substrate, 50% perlite and 50% worm castings, is a good substrate for growing a plant, because you've got the 17 essential nutrients for the plant to take up, and you've got the right amount of organic matter, being the worm castings, and it's porous enough so it'll hold a lot of water. What substrate do you recommend for germination? Well, water. You grab seeds, put it in a cup, run distilled water over the top of it, and put it into a bag and leave it. And then, if you haven't done it, you'll know if your environment has a lot of pollution, or not pollution, but bacterial and also fungi in the air, because it'll start and pollute and grow quite quickly a biofilm, or it might turn green from the fungi or different algae that's in the air, spores that are around. And then after that few days, then you know that the seed's taken enough water. Then you can probably proceed into a substrate, into a solid substrate, not aqueous, and then into something that's going to, like you said, it's good having 50% perlite, 50% worm castings, but it's going to dry out pretty fast. So you're going to remember those perlite. If you use coarse or large ball type ones, that means there's going to be a lot of air around it. So you can pretty much say, if there's a seed sitting on that's just germinated, and you water and it stays there, that within 5 or 10 minutes, there's going to be no water around it. So it could start to dry out. So they're things to consider. So you could even use that as your substrate. And if you're starting a seed, you could use some peat or cocoa or rock wool, like Matt said. So you put the cocoa in grab a golf ball size and put it right in the middle, and that might be where you're going to put the seed or seedling. So it's not going to dry out as fast. And then by the time it's a few more days, a week's gone on, its roots big enough, gone into the perlite section, and it's going to be enough to grab moisture around all those areas around the roots that's going to put out. So it'll be right. And hello, I didn't say good day. How you going, Matt? It's nice to see you. Actually, you're not, I remember you coming in another time. There you go. Sounds interesting, says. Yes, sunshine. Yeah, because once you get the principles down on the technology, like in here, from knowing these, is it still up? Yes, it is. And how far it goes. So by knowing, oh, look at this one. Oh, that's for, what do you call it? Pollination. I like these. Primordia. I lost what I was saying. So by knowing these stages and what it requires, you can put it under different conditions and still succeed. Quiescence. Seeds are not provided with adequate conditions like water, temperature, or air for germination. So you do not want quiescence as perfectly timed. So by knowing that they require those three things, and you can see what the substrate is and your conditions you're putting it under, you can make your decisions. Oh, now we're getting into dormancy. Primary, secondary dormancy, yeah, that goes right into it heavily. Stop sharing, I think. Is that, what else can you add to what you're saying, Sunshine RB? Because that was pretty cool, going into the germination. So I could go more about seed technology. Lurk says, Matt. That's cool, mate. All right, I'll just show some more seed technology stuff. That's an interesting week. They're not even saying. Yeah, we'll get into it then. See what interesting facts come up. Senescence, the phase of the aging. Stored food is consumed for respiration, the catabolic period. Because yeah, for your metabolism, or for plants, they have the same cells as humans, the prokaryotic and what's the, I can't even blooming, we got the same cells. So for the metabolism to happen, it needs a catabolism, which makes the energy, and the anabolism uses it up. So that's why leaves last 45 days, as I always say, from this. So on the left, on the y-axis, is your chlorophyll content. On the x-axis is your dosy, so how alive it is. So it's very high there. After 10 days, it's peaked. Now it's stored. So after 15 days, it's said to have matured on this test that they've done. Then after that, it's going to start an age, and then it's going to be used. So it's gone as sink and source cells. Actually, we'll change the topic a bit. I won't go into that then. It's sink. All energy's gone into the sink, and then it's become a source cell. So then it's going to be used up. That's how the plant functions with its nutrient cycling. If seeds are exposed to high humidity or rain during development or harvest, then they age faster. The only problem with that too is you're running into fungal problems with high humidity and rain. It's technical stuff. Keeping seeds mature in cool, dry weather will avoid weathering damage. Okay, about protecting them. Spraying, I don't promote unless it's bio-fungicide or bio-pesticides. Farmers use only 24% of quality seed and suffer from poor germination, uneven maturity, and reduced yield, as you can see here. Poor fella. So to summarise the above, we can say that quality seed should have all of these characteristics. We're right out of the topic. Let's see if there's anything said. So that was, we're into germination. Sunshine says biochar. 50% biochar, 50% worm castings would be interesting. Yeah. Well, biochar is rad for microbe houses, because the oxygen that's being created in the organic matter from the high temperatures allows little homes for microbes to live in. So that's a perfect space for them to occupy. So that's why I really, really like biochar. And you say a substrate with a 50% blend of it. I suppose. Well, if you compare biochar to perlite, biochar's got a lot better properties to perlite. Perlite's, isn't it volcanic? P-R-L-I-T. Let's go to that one. Share the screen. Where are we? All right. Let's compare Perlite and Biochar. Biochar is better. It's probably more expensive too. But Perlite, it's an amorphous volcanic glass that has relatively high water content, typically formed by hydration of obsidian. Okay. The typical analysis has a lot of silicon dioxide. Oh, it's got aluminium in it, aluminum oxide. And you know, from the cation exchange, that's the baddie. That one, mega bad. That hogs the cation exchange. That's a positive cation, and that's right on the cation exchange. The bonding strength of the cations, that's the top one. So it'll knock out anything else underneath it. So 12%. That's pretty interesting. Biochar won't have that. But this also has potassium, sodium, which is a iron, magnesium, calcium. They're all, and silicon. That's a beneficial, but the other ones, they're all essential elements for plants out of the 17 essentials. All right, let's have a look at, I'll have to put that in the search engine. Biochar. Biochar is charcoal, sometimes modified, that is intended for organic use. It's formed, I'll wait till they say how to do it. Biochar is mainly used, no. It's formed by organic matter at high temperatures, consists of carbon and ashes remaining after the fire of biomass, and they form charcoal. But there's a difference between charcoal and biochar, though. See how they made it here? So all they're putting is wood and getting it to a nice high temperature. But you have to watch the temperatures, because if it goes too high, that's when over 1,000 Celsius is calcium's released, volatilized, so it's not good. So you got to keep your temperatures low. Temperature during pyrolysis is, there you go, those temperatures in reduction zone and in combustion zone. Anyway, let's see the properties, not how to make it. Crops used, hydrochar. Hydrochar, wow, so they add, hydro's water, so they add that to water to it. That's pretty cool. Properties. Physical and chemical properties of biochar as determined by feedstock and technology. Fruits. Properties can be categorized in 7 aspects. It doesn't really say the breakdown, the chemical breakdown. Excuse me. Improve soil health. Biochar offers multiple soil health benefits in degraded tropical soils, but is less beneficial in temperate zones. Its porous nature is effective at retaining both water and water-soluble nutrients. Biochar reduces leaching. For plants that require high potash and elevated pH, biochar can improve this. So perlite doesn't have as much benefits as this. Application slash and char. What's that mean? Switching from slash and burn to slash and char farming techniques. What's that mean? Slash and char is an alternative to slash and burn, yeah, that has lesser effect on the environment. In this practice of charring the biomass, resulting in slashing instead of burning it. Due to the incomplete combustion, the resulting residue matter, charcoal, can be utilised as biochar to improve. So what's the difference between slash and burn, slash and char? Charring the biomass resulting from the slash and charring. Charring is a chemical process of incomplete combustion. When subject to high heat, heat distillation removes water vapor and VOCs from the matrix. The residual black carbon is char. All right, well, I'm still not really a bit confused there, but that's what it says. Okay. So I've got to stop sharing. I'm not sure where I was at there. I got a bit carried away. Oh, there's a few more words. Add 10% rice hulls. Yeah, I suppose. Well, the rice hulls is good for aeration and it'll break down as well. But you don't want to make your substrate too rich. Remember, if you've got too much nutrients in there, that's going to create a sodic problem where there's too much salts. So be careful with adding too much goodness. You can overdo it. All these things are very good, but you've got to put them in smaller amounts so the plant doesn't suffer for it, because you can overdo it and make toxic conditions. Hey, there's Lene. Hello, Lene. How are you? Hello. Hello, Blinky. Long time no see. In some weeks. Yes, it's been a while, Blinky. You got any questions, Blinky? Questions on soil science, plant science, and microbiology? This is going pretty well. Hello, hello. Good, thanks. Good day, g'day. And we're talking a lot on germination. That was quite good. I enjoyed that and going through some seed technology classes. So if there's no more questions coming through, as I see, let's just get back to some seed technology. Add your discussion topics or questions in the chat, please, and then I can see them, and then we can go from there. Otherwise, I don't see any now. I think I've answered Sunshine's question as far as I was aware, and we started to go through the seed technology stuff again. This stuff. That's right. Went through that. Summary. I'm not sure where I was up to. There it is there. Good seed makes a good crop. Isolation. Oh, okay, putting barriers up and stuff. It's for making seed. Yep. Factors influencing isolation distance. Okay, that's a bit technical. What's that one? Down the bottom. Emasculation and dusting. Emasculation. Well, emasculation's an E, removing the male bits. That's what that is. And then dusting. So you've got pollen in there that you've saved, and they've got a little paintbrush, and you just go and dust it on. Put it onto that. Isn't it amazing that different pollen has different characteristics under the microscope? Pre-sowing. So a big thing is to soak your seeds, like I was saying, because it needs those three things. Temperature, oxygen, and water. So in here, they've all sunk to the bottom. So water is 10,000 times slower available oxygen to the plant. So that's why it's best to try and leave them soaking on top. Or if you just have a little lower a bit in the bottom there, they can still access oxygen, making that process a bit faster. So those few slides would have been good at the start. Seed hardening with different chemicals. Or you can, seed soaking is really good, like it was just on the previous. But that's when you'll start and you can soak things. But when you're soaking them in it, it's not really going to get inside. You're putting it on the seed coat. And then that seed coat is just around where the roots are going to be, and then it touches the roots. Because you've got two different types of inoculants. The ones that go inside the cells, and then the ones that stay on the outside. The epiphytes and endophytes. Depths to sow. Yes, This is pretty interesting. A good, really cool rule of thumb. The sowing depth should be double the diameter of the seed. So if it's 1 centimeter width, it should be 2 centimeters depth. Just a good rule of thumb. So the bigger the seed, the further down it goes. And those little tiny sesame seeds and their lettuce seeds, yeah, sprinkle them on the top and just dust a covering over it. Carrots, the same. Harvesting seeds, chemical stratification, no. Seed storage is very important and often forgotten about. People just leave it out in the air, and it's got a living embryo inside of it. You've got to maintain it if you want seed to maintain its viability. So I suggest it's got to be in low temperatures and low humidity. Bottom back at the fridge in Tupperware containers with unboiled rice around it, so that absorbs moisture first. Well labelled, dates, everything. So it'll look like that. You might write on the bag, but it's got to be well labelled. Or you could even, I just use Glad Wrap, put Glad Wrap, cling wrap down, a few layers of that, write on paper what it is, when, different information it might have, its parents, all sorts of different things. And then you've got that bit of paper underneath the cling wrap, and then just wrap it up. And the cling wrap on top you can see easily. So that's a good way to do it. So using bags. Let's see what else there is in seed technology. Senescence. Yeah, this is pretty cool, isn't it? Remember like that diagram before about leaves lasting 45 days? So it gets up to its peak and it starts to age from its source and sink cells. What's this? If the seeds are dried to the lowest moisture content, about 10 to 12%, respiration will slow and the seed senescence will be slow as well. So when you're drying it, that's when it's still on the plant. But you don't want to store it above 10% moisture, definitely. If the moisture content is high during maturity, respiration will be high and the seed senescence will be faster. There's some interesting points. So while it's still in the plant, low moisture will have a low seed senescence, because it takes about 25 days to produce a seed for it to mature. So if your conditions are low, it might take 30 days. And if you have a high moisture during seed germination, it might be faster. So you might get it, say, 22 days instead of 25. Beyond physiological maturity, seeds lose moisture and they're amenable for harvest and storage on mother plants or shed to the ground. Cool. Oh, I don't want to go into that, eh? This is pretty interesting at the bottom, though. Seeds can be classified into 3 types: micro, meso, or macrobiotic. So it's just the seed sizes. Micro is so small, meso's in the middle, macro's humongous. And yeah, micro, the smallest ones, that's the only difference. The smaller ones age faster. So your shelf life might be 12 months. This might be 2 years, and the macros might be 3 years. But if you store them in good conditions, you can double, triple, even quadruple those times for storage. Oh, there you go. It even says it up here. The mesos were 2 to 3 years. I said 2. And bigger ones, 3. And when you store them, they've got to have no organic matter around it, meaning all debris, bits of sticks, twigs, pollen, anything like that, because that's the stuff that's going to have bacteria and fungus on it that's going to start and mold and break down things. So it's a good way to get rid of that, because the seeds weigh heavier than air, so you can blow. So if you put them out in separate, all the stuff you blow and it just blows away. For seed separating machines, it's what they do. They use air a lot. So yeah, seed embryos are protected by the hard seed coat that prevents the entry of moisture, and respiration is reduced, and seed senescence is low. So it's amazing. So that they're actually alive inside of it. They're just in a stationary dormant stage. Influence like pests, bugs increase seed senescence because injury by pests increase seed metabolization, causing seeds to age fast. But if you have them in the fridge, in a Tupperware container down the bottom of the back, you won't get any stuff like that. Diseases, so different bits of plant material have things on it. So that's what that's saying. It'll age your seeds faster because they'll start to metabolize. Injured seeds become permeable to moisture, leading to faster metabolization and therefore seed senescence, and you won't be able to break its dormancy unless you've got to do some hardcore tissue culture. Recalcitrant seeds, high metabolic rate and age faster. High senescent seeds, reducing the seed moisture during processing, handling time and transportation time will reduce seed injury. So how you process the seed also. Isn't that interesting? So touching the seed coat ruptures and starts their metabolization. So all these things, so isn't it amazing how you've got to be so protective of it, and people just think, oh, it's just a seed. It's in dormancy. What is it? But these are the processes that happen. So now that you know that, and then you got seed storage, well, that's their commercial seed storage. But now from knowing the different stages it goes through and what it requires, you can make your own decisions, educated decisions on, am I treating it right? Is it the conditions that it wants? Am I babying it enough to make it last? And now it goes into physics and the seed quality. Well, as long as you get it to go mature, you get it to go at least, actually that's pretty important. Seed maturity stage. I know it's one of these, so I made a slide out of it. This one. So as long as you get it to go to 25 to 30 days. See, after, up here on the top x-axis, seed formation, maturation, post-abscission or ripening, and then dispersal post-harvest, aging, and then it's repairing itself. So this line here, day 30, and here was about day 25 odd. So you could say day 25 it peaks. And remember what I was talking about in moist and humid, the humid and dry. So this changes a smidgen as well. But in general, 25 days. So as long as you get loads for 25 days, you should be pretty right. Actually, I should stop sharing. Been talking for a while. G'day. No, I was how do you germinate seeds? Yeah, that's what I was talking about at the start. You need those three things, Matt: temperature, oxygen or air, and water. So that's why that slide showed it pretty good. Hopefully it'll be in here. There's a few back from this, where it had the ones that were just laying on top of the, no, it's not that one. There it is. Yeah, so they had the peas here that they're laying. So they're giving them water, they're giving it oxygen, and then the heat. So they're the three things it needs. But if you've got here, if it's sunken down, for the embryo to get the seed to get the oxygen out of water, it's 10,000 times slower. So I like to float mine or put it in lower amount of water just for that reason. Paper towel technique, like it's suggested down here, is really good. So you soak them for 24 hours. I'll do mine for, I don't mind going quite a few days actually. Depends if you're going to get bacteria film or starting algae or anything like that. That's when I'll stop, because that's not helping the process. But then, yeah, they're moist enough so they absorb water. So then all they need is oxygen and temperature. So you can throw them into paper towel that. And then in the paper towel, you put a plastic bag around them. So it maintains that moisture because it dries out very fast once it gets into the paper towel technique. That's what that says. That helps, Matt. And at the start of it, we were talking pretty extensively about it too. How do you do it? Just that way. Leave them floating on the top for quite a few days, and then you'll see that's given them maximum oxygen, maximum water from below, and the temperature should be fine. Room temperature up to 30 degrees, or so that's 81 F. Watch out those heat trays, those heat mats, because where the heat is the bottom of the cup, and it's going to slowly get into it and make it really extra hot. So I don't use that. I just put a position where it's going to be maintain a optimum temperature. In other words, don't do it in winter. Have a lot less luck. Blinky says this winter I used a heat blanket in those nursery containers. Yes, those are actually cool. They were what I was talking about. Want to get one with a thermostat on it, and well, I'm a Sparky, so I put a thermostat on it, and then that thermostat has a probe. So I put that probe into the medium that the seedlings are starting to strike in, and I maintain that temperature. I don't know if you can buy them, but you can make one. They could probably buy it for top dollar. But yeah, that helps, because remember the three things again: the temperature, the oxygen, and the water, moisture. So by maintaining its temperature and dialing it in, you've forgotten about that, and you're nearly going to 100% give the seed what it wants. So you've got the right conditions to break it out of dormancy. So the only question then is how viable are the seeds that you have? Because if those persons have put it under stress, the seed's under stress, if they've not let them ripen properly or go overripe, there's all these things that are going to make the seed harder to germinate. All right. Hello, Ciolini. Hello. I tried the method with the oven drying the bud. Oh, yeah. That's good. And I hope you kept watch the end result. It's from the video. Nice one. And that cure, and it worked. Yes, well done. Yes, that's why I put it up there, because I don't put false or fake stuff. I've done science for many years. Well, being a scientist is one that you're adding to the science community. So I've liked to contribute to the plant, soil science, and microbiology community. So yeah, I'm glad you had success and from it. Thanks for the feedback. Yeah. That says, cool, thanks. I presumed that was helpful, yeah. And watch from the start too again, Matt, because I go into a little bit more detail, because that was summarised at the end for you. Blinky says, yep, thermostat with probe. Yes, I did. Cheap, really. Oh, okay, you can get them with that. Oh, excellent. Because, yeah, there's no worries with it then. Otherwise, the problem with it is they sit on too long, and it heats up the air around it. Wherever the thermostat is in the little, near the plug point, that's where it regulates itself from. So by putting in a probe tip, you can put it into your medium or water or anything. It helps heaps. So that's, yeah, taken out. That's really good. Hello. G'day. Then cure over a week. Bang. Yes. Just reading in the chat here. Yes, you've got to take them out or keep that door open. Yes, well, you've got to get it to the right moisture. Then once it's at the right moisture you like, then you've got to bag it and cure it for over a week. Yes, I've the reason why the curing thing is I had what was it, about 10 days. 10 days, and I noticed the profile had changed dramatically. So that curing process is, it's vital and one of the important steps to complete the process. So I'm glad it worked for you. And what else we're talking about? And the germination. So, all right, let's go through. There's another question. Being spring, summer with cold nights, still I'm concerned about taking girls outside yet. Well, you have to wait for short day plants or long day plants. The short day plant doesn't like the time to go longer for it to flower. So you've got to make sure that your environment that you're putting it in has those hours. So if you're going in and it's a 12-12 environment, and that means it's going to flower at that stage around the equinox. So if you want to wait a little bit longer, you can put it in, if you've got horizon to horizon, sunrise to sunset, and 12 hours sunlight, or say 12.5 to 13, it might flip it into flower mode. But so you just got to watch the environment you're putting it in. Just cut a long story short. If you've got trees blocking it, things blocking your plants, stuff like that, the plant will only recognize the hours of sunlight. So you might put it into flower. So just be wary of those things. So you want to catch as much as you can. The other alternative to that is if you've got no option, you only get 6 hours of sunlight, you can always use supplementary lighting just to pull it out of that phase. I hope that helped. Let me know if that didn't help, and I'll elaborate a bit more. So yes, as to taking them outside, as long as there's no frost, that's the one thing the plants don't like, and that daylight hours, the photo period. Oh, good. I'm glad it helped. And then too, all right, I'm glad it helped. Right, I'll just stay on the germination thing. Let's go back and see what that seed technology class on germination had. No, under my things, that germination. My notes, not seed technology. Germination. Let's see what's in here. I started to go through these before. I'll start here. It's already open. Why didn't it just pop up? Germination. What's interesting? The caruncle. I like that name. That's like the bulby bit, the chunky bit, on where the root first comes out, the radical, because it's so that's on all seeds too, because that means the top bit over here is going to spread first, and that's where the cotyledons start. And the hypocotyl stem, and down those roots come out where the micropyle is, where it gets fertilized. But we're talking about, stay on the topic, germination. Certain regulating hormones also percolate into the endosperm from the embryo axis, like ethylene, therefore helping and aiding in the process. Okay. in germination. Trying to find something that might be cool to elaborate. Growing embryo expands and breaks the tester. The tester is the seed coat, and then the radicle comes out first and grows into the primary root system. So there's a little radicle. Mango. I'm actually trying to do that at the moment with a couple myself. Groundnut. My groundnuts aren't growing. Tester, there's the seed coat, the tester. The embryo swell, expands, and may break the tester. So it's how when the water comes into it. Without that, it's not going to expand to break the tester. Up the top, for it to start to, in the embryo, the cells begin to elongate and divide. This must be that water enters and the embryo swells. It expands and may break the tester. And then the embryo cells begin to divide, elongate, and divide. The radicle grows actively and emerges out of the seed coat. And see, this is a good example of when to inoculate. So if this was inoculated, you can soak seeds in a bio-fertilizer, biopesticides, beneficials before you put them in, and then you'll pull them out, let them dry on the seed, and then inoculate it within 24 hours. Plant it within 24 hours. So it's once the radicle comes out, it's trying to look for microbes to help it. Remember the rhizophagy cycle, how the microbes go out through the hairs, out through the tip, and then back through the hairs like that. So they're looking for beneficials. So the ones that are on the seed coat, or the tester that you've gone and put them on, might have gone on the root tip. So where it comes out through that little micropyle end, it's going to grab which is the microbes that are in that area. Remember, the size of the life cycle of a bacteria is one full stop on a piece of paper, a dot. So that dot there is its life cycle, how far it can expand if it hasn't got any flagellum or cilia to help it become motile or move around. So from it being inoculated there, you hope that it's touched and gotten on that spot. And then it can continue to repopulate itself and stay with the root tip as it moves along, but it might die off. So all of this is going to be beneficial, but it's got to be transported. So how can it? So earthworms and stuff transport it, or you can put another dose on. So when you see the roots, that's a good time to put the dose on of beneficials, because then you've got to check to see if they're ones that work on the inside, the endophytes, or the ones that work on the outside, the epiphytes. Because the ones that work inside, they'll stay with it and pretty much its life cycle, because they'll just keep producing. But the ones on the outside will only stay in the phyllosphere above the soil, or the rhizosphere around the roots. So you might have to, once it keeps growing, re-inoculate, because the roots get longer and it mightn't be around it anymore. So that's a good time, that's a good explanation for this. Germination. First, the green leaves make their appearance, become green and start photosynthesis. Then you know you're pretty right. Then you might want to do another inoculation of the leaves to start and work with your phylosphere, if it's ones that work on the outside, the epiphytic bacteria, which, to be honest, from what I'm finding, most of them are. There's only, well, I shouldn't say, well, the ones that I'm working with, the dozen or so, there's only a few that work inside. Most of them work outside. Structure of a gram seed. Okay. Cotyledons, which are those first little leaves it puts out, which are the stored leaves. They're there for the energy. So that this slide says cotyledons, which are thick due to the food storage, absorb water slowly from the seeds coats and also through the cotyledonary stalks from the embryo axis. Pumule grows and gives out the first green leaves that start manufacturing food. Viviparous germination. No, we're not going to go through that. It's a really weird plant. See how it strikes down. Actually, that's a different type of root system you probably don't know about. You know, there's 3 types. There's the big taproot, which is your taproot. And you've got adventitious roots, which walk out like that, usually from cuttings. And then you've got stolen roots, which are ones that grow down and they will touch the soil out here, and those ones that are stolen. So this could be a form of a stolen root that's coming and branching out differently. Stolen root system, but it's a viviparous germination. So just something interesting. I was just going to, roots may be buried in the shallow water. Oh, that's because we're talking about viviparous. Tomatoes not viviparous. That's it for germination slides. Sweet. Probably better for the sharing too. All right. Matt Cialini says, in summer days, if I want to dry outdoors and at the point when it bends, I want to sweat them in a plastic bag and loosen the knot and leave it overnight under the tarp. No way! No. No, Ethylene, because it's sweating, it's got too much moisture inside of it and it'll start and rot very fast. Bacteria start and reproduce in high humidities, and fungus is even in lower humidities at about 65% for fungus. So if you've got any spores around them, which you do, everyone has them, they're in the air everywhere, that's what will happen. So no. And next day, you would open it and dry it to dry and smell clean and close it and cure. No. You're kind of nearly doing a ground cure technique, it's called, an Asian ground cure, where it's an anaerobic cure, where there's no oxygen. And that can be dangerous. But that's how they used to do it back in the day. But I don't advise that one blooming bit. That's why I made that video on how to dry flowers fast. For that reason, it maintains all the medicinal properties. So you don't want to knock any of them out. And putting through different processes, heat processes and moisture processes will knock some of them out. CO Lini says, so basically that's first sweat, you do it in open room. I know you're trying with your language. It didn't come through real good for me to understand that one. So basically the first sweat. I don't sweat it at all. It's just a drying process. So I like my result to be 10 or 12% moisture. So I just dry it. It can be done quickly, like in that video I made, or it can be done slowly. You just can't over dry it because it'll be too brittle and lose a lot of its properties, and under dry leaves too much moisture in there and it's going to cause fungal problems down the track when stored. So it's about all I can. I hope that, does that help, mate? Like, change your words if that doesn't help, because I don't sweat it. I don't do that sweating technique. I don't. Once it's dry, they're dry. And then you'll open your storage thing and smell maybe the next day. And if you've got a good smell, you'll know if it needs to be dried more, or if it's got sort of a wettish smell, that's not good. And that's when it's got to be, dried more. But if it's got like a nice sweetie or smell that should be, should be good, You just know if it's too wet, and then you'll learn if you don't know. So you put a bit in, you think, oh, this is all right, and then all of a sudden the smell gets worse and worse. It wasn't right. So next time, make it drier, and you get into a habit of just leaving it 10 to 12%, or buy one of those wood moisture meters and do your own experiments, and then you can get your flowers down to whatever you want. Putting your prongs in. Get the 4-prong too, not the 2-prong. So I hope that helps with your finishing of your result. One of my classes was post-harvest operations in agricultural crops, and it was pretty fascinating to go through and see what happens with the cells after the plant has been harvested. So you've got to protect it right until the end, right until. I hope that helps, mate. Oh, here's another addition. I always dry it until it's almost dry, and then I take it into a closed room and leave it there overnight. That's wet. And in the morning, if it's sparkle and dry, I jar it for a week. Okay. You might be benefit in a $35 US, about $30 US dollars for a wood moisture meter. Maybe look one of them up. And then you can learn how dry things get, and then you'll know pretty quickly when you can bag it and when, because by leaving it out in the open air, there's a chance things are going to land on it. And no one's got sterile conditions in lab sterile conditions, so I just try and get it as fast as I can into sealed environment, so it retains all its properties that you want. Oh, there you go. Thank you. You're welcome. Thank you, Cioloni, for your questions as well. I like questions. No question is a dumb question to me, even if it's because that person asked it. They don't understand it. I'm not one of those persons that criticize silly questions and stuff, because we've all got to start somewhere. And that's where the cool people in chat here, they'll help me out a lot too. They'll put in what they've done, their experiments and results, and yeah, then you can make your own decision. Because there's no real right ways to do things. There's just many different techniques for different situations. Yes, we're going for an hour. Well, quickly get your stuff into chat, or I'm going to call it a germination show. I probably could have went into more AussyCC technology stuff, but it's been an hour and all the questions were answered, so I think that was pretty good. So I'm going to call it. So I hope you can join next week. Everybody who listens and listens back, trying to join the live, just come say good day if you want, please. That'd be nice. Thought it was nice to hear from cool people and new people, even old people, even those people that aren't so good. If they be polite and respectful, they're welcome as well. Yeah, that's about it. Thanks for listening, everyone. Happy breeding, happy growing, and good health to you all. Bye-bye.